This is a review of our topics from this week. We have loci and construction, harder ratio questions, and similar shapes. Let's start with construction. The first question here is asking for a perpendicular bisector of the line AB. So perpendicular means it's going to be at a 90-degree angle. It's going to meet the line at a right angle. And a bisector, if it bisects it, that means it cuts it in half. So it's going to be exactly in the middle of A and B. So we use our compass and we're going to place the point on one of the ends. So either A or B, doesn't matter which one we start with. So I'm going to place the point on B, extend it out beyond halfway and draw an arc. Then I'm going to do the same thing at A. So I'm keeping it exactly the same length. I'm not changing the length between the point and the pen. That's staying the same. And I'm going to draw another arc from A. So what we can see is we've got 2 points where our 2 arcs have intersected. So one here and one here. So if we join them up, that line is our perpendicular bisector. So this is a perpendicular bisector of the line AB. The second question says bisect the angle at A. So again, we're using a compass and we draw an arc from A. So the point of the compass is at A and we draw an arc and we get 2 points on these 2 lines on the line AB and AC that are exactly the same distance away from A. And once we've got those 2 points, we take our compass again and draw an arc from one of them and then put the point on the other one and draw an arc from the other one. And what we get is we get a point exactly halfway between the 2 lines. So if we join up the point we found with the angle A, we cut the angle in half. So this line goes exactly halfway between the line AB and the line AC. We could say it's the locus of all the points halfway between, equidistant from AC and AB. That cuts the angle in half, it bisects the angle, and that's what we wanted to do. This question says C is the point equidistant, so equal distance to A and B, and 5 centimeters away from B. Find the 2 possible positions of C. So we need to draw a line, the locus of all the points equal distance away from A and B. So we're going to get the compass, extend it beyond halfway, draw an arc from A, so the point of the compass is at A, then move the point of the compass to B, and draw another arc. So what we find 2 points that are exactly equal distance from A and B. And if we join them up, that becomes the line, the locus of all points equal distance from A and B. So there are all the points equal distance from A and B. We also need 5 centimeters away from B. So we need to measure 5 centimeters. So our compass needs to be, the pen needs to be 5 centimeters away from the point. And that's from B. So the point goes on B. And we draw an arc 5 centimeters. So that's the circle. That's the locus of all points 5 centimeters away from B. So where are the 2 points? So where the line crosses the circle. The 2 points equal distance away from A and B and 5 centimeters away from B. Harder ratio questions. Here we're told the ratio of adults to children in a cinema is 4 to 3. 60% of the children are girls. What proportion of all people in the cinema are girls? So what fraction of everyone in the cinema are children? So the ratio of adults to children is 4 to 3. 4 adults to every 3 children. So we can say 3/7 are children. 3/7. There are 7 parts in total. 3 parts out of 7 parts are children. And 60% of them are girls. So it's 60% of 3/7. And we can change of into a times. So we're after 60% times 3/7. We can, well, we could type this into the calculator, or we could change it to a fraction. So 60% is the same as 6/10 or 3/5. So we want 3/5 times 3/7 times the top times the bottom, and we get our answer of 9/35. So 9/35 of all the people in the cinema are girls. Question 2. Given A to B is 4 to 3, so for every 4 of A, we've got 3 of B, and A to C is 5 to 2, find the ratio A to B to C. So we need to make the A's the same, because A is in both of these ratios. If we make the A's the same, we can put them together. So to make the A's the same, I'm going to times my first ratio by 5 and my second ratio by 4, and that will make A 20 in both of them. So we're after an equivalent ratio to A to B. So if I times these by 5, 4 5s are 20, 3 5s are 15. So 20 to 15. An A to C ratio times 4. 4 5s are 20. 2 4s are 8. So I can say the ratio of A to B is 20 to 15. The ratio of A to C is 20 to 8. So I can say A to B to C. For every 20 of A, there are 15 of B and 8 of C. So 20 to 15 to 8. And similar shapes. We can say that shapes are similar if one is an enlargement of the other. And if one is an enlargement of the other, we can find a scale factor. So A, B, C and D, E, F are similar shapes, and the length BC goes with EF. So we can use them to work out the scale factor. So what do we do to, what would we have to times 10 by to get 25? 10 times what is 25? If we do 25 over 10, that's 2.5. So to get from 10 to 25, we times by 2.5. The scale factor is 2.5. To go from small triangle to big triangle, we times by 2.5. And to go back from the big one to the little one, we divide by 2.5. So find the length of DF. So DF goes with AC. So it's going to be 8 times 2.5. 2 8s are 16. Half of an 8 is 4. So 16 and 4 make 20. So DF is 20 centimeters. Find the length of AB. Well, so AB goes with DE, so it's going to be 20 divided by 2.5, which is going to be 8 centimeters. So we've got 8 centimeters and 20 centimeters. So we've actually got a nice isosceles triangle, 2 lengths the same. Here's one for you to try. So give this one a go. So again, we've got ABC and DEF that are similar shapes. So we know AB and DE, so we can use them to work out the scale factor. 9/6 is the same as 3/2 or 1.5. So to go from the little shape to the big shape, we're going to be timesing by 1.5. To go back, we're going to be dividing by 1.5. So find the length of EF. EF goes with BC. So it's going to be 7 times 1.5. 1.5 sevens is 10.5. And find the length of AC. AC goes with DF. So it's going to be 12 divided by 1.5, which is the same as if I double top and bottom, 24/3, so 8 centimeters. So that was our week 12 review. There's an assessment now available. The link will be in the description or at the bottom of the page on the website.